Welcome back to Daily LeetCode, day 61 of Daily LeetCode. We are back once again. We've reached quite the milestone, day 61. I was thinking about dropping a video called, 60 Days of LeetCode, and the title was gonna be like me like what I learned for 60 days of LeetCode or something like this. Something like this. 60 days of LeetCode or something like that, but we'll see if that is coming. Maybe it will be recorded tomorrow, maybe it will be recorded next week, but I was thinking of maybe like doing like a streaming thing where maybe we'll do like one problem live or something like the grind live or something like that, maybe like one day a week. That could be pretty cool, building like a community or something like that. Remains to be seen if it should be done on something like YouTube or something like Twitch, but who knows, right? Who actually knows? Maybe we'll do both. Maybe we won't do both. Maybe YouTube is fine. I don't know. But yes, I just reflections on yesterday. Oh, actually, yeah, W session yesterday. I feel like there was huge progress made. We had our homeboy Thomas. You should mock the weekly contest tomorrow. LeetCode 2373 to 2376. I'm actually not sure what the weekly contest is. So I'm actually not sure what these mean. Contest every week. Compete and see your ranking. Claim secret reward. 10 lead coins. Nice. It's this Saturday. Wait, I think we missed it. It's Saturday, right? It's Sunday. Bi-weekly contest, featured contest. Oh, I should mock it. Oh, I missed it. Oh, I think I see what you mean. I missed it. So it's actually, these are the problems done. 2370 to 2376. Interesting. That sounds pretty dope. That sounds actually pretty cool. It looks like there's some cool machine learning like input here in terms of like looks like some kind of depth map. That looks pretty cool. So yeah, we could try something like this. I'm still kind of going through. We have some cards to do today. I said I wanted to spend more time. I want to try a new version of trapping rainwater, right? It's really very strange. I've been having a lot of growth actually doing. I used to just do all the problems, do the same solution I usually did and explain it. That helped a lot, just explaining my solution and learning it. I'm also learning that there's always like space. There's like space to explore. It's kind of strange. We're like trapping rainwater. The solution I came up with was linear time, but it's kind of like a two-pointer approach. I'm wondering if maybe we can intuit the DP approach, right? So I want to spend some time on that. So that's what we're going to do today. And then I feel like we're actually getting, in a really, really weird way, we're getting close to solving evaluate division. I was doing some reading from the ADM, right? And there's too many gems in here. The ADM is unstoppable. There are too many gems. So I think there's a cheat code to be had in this problem. Also, there's a section just reading about breadth first search and how it's pretty much crucial for shortest path problems because you expand out. The newest nodes, right, are processed first. So there's also an array you can create called a parent array, which looks very, very similar to like the rank or the root array in like the union find data structure. You can actually use to find the shortest path. So it's just very, very interesting, right? So I think in a weird way, we could probably dunk on snakes and ladders now. But additionally, I have no doubt the next time I do coin change, it's going to be a beatdown. It's going to be a beatdown because I think we have the tools now to solve it. So the ADM, you got to cop this right now. This is one of the holy texts of the computer science discipline. You're going to want this on your shelf. Buy a copy for your mom, your dad, your sister, your niece, right? This is one of the great holy texts. We also had daily code, make him yet. I'm just that guy coming daily homie, man. You are the daily homie. Feels strong, man. You just can't beat it, right? Thomas dropping the knowledge bombs, man. This sounds fire. I'm feeling this after I get past the it's tough, right? Because I'm trying to do this explore card thing with the graphs, right? We're stuck on evaluate division, right? And we keep creating these side quests with the review problems. It's just a strange situation. So we're actually being blocked. I'm wondering if I don't know. I think we're definitely getting sidetracked, right? Because I'm learning so much by doing the old problems, right, in new ways. It's kind of crazy, right? Because all this started in a weird way with coin change, and I think another problem, snakes and ladders. And so in a weird way, there's like been a really weird like amount of growth just by doing these old problems. We're still stuck on evaluate division, but I haven't given it enough time yet to actually figure out the problem. And then it's fine because I think the slower it's like this. I think there's like a new paradigm, right? There's a way like I feel like I have to do a bunch of problems, right? But I feel like there's another way, like if I really, really like osmosis the depths of the problem, then we can actually learn more by solving less problems. Kind of counterintuitive that way. That's kind of how the process has been so far. But I know for a fact we are currently unable to solve optimized water distribution, because every graph problem I've ever done has been on an unweighted graph, and this problem has a weighted graph. So we're getting there in the ADM. So I think we're gonna have a way to solve this soon. But yeah, I definitely want to try and mock the contest. I wonder if like people, how often are people mocking, like how often are people doing these contests? So that'd be interesting to see. Sounds fire. Say no more, brother. I will try to get to this one soon. So many problems to do. God bless LeetCode. But yeah, I also started checking out the system design primer by Don Martin. So that was pretty dope. So I think the first section. So I think the way to do it now, since the Copy Ninja gave me a tip from the buffest scientist on the internet, Andrew Huberman, about learning intervals, and the best, I guess, learning length is about 90 minutes, like 90 minutes to 2 hours. So I think we're going to try and do 2 hours a day. But the breakdown is like this. So we do 30 minutes of system design, right? 30 minutes of reading the ADM, supplemental reading is key. And then 1 hour of LeetCode. So that's why you have an hour set up here. But yeah, so the only thing I haven't mentioned yet, the system design primer was pretty dope. So I was watching the first part of it, right? And it's basically the scalability lecture by David Malin from Harvard, I think. Man is a legendary teacher, legendary orator, right? So that was pretty dope. The lecture is like 2 hours long, so I'm going like 30 minutes a day, which is probably better because I'm spacing it. So each time I'll come back to it, it'll be a little bit better or a little bit easier to digest. So after like 60 minutes of lecture, honestly, less than after like 30 or 25 minutes of lecture, it's just hard to keep the puzzle going in your head, right? Because the professor's talking, you're changing the puzzle in your head, right? This decision tree of like information, right? And then after a certain point, you're just like, I can't follow anymore. So stopping at 30 minutes makes sense, but I'm just glad we're making progress with the system design. So I think we have all the pieces in place now. Now we just have to put in the time in. So I'm honestly thinking like 4 months or something like that, we're gonna be a problem. We're gonna be a problem. Everyone in the channel is gonna be a problem. Everyone in the HCC is gonna be a problem. So that's where we're at, right? So plan for today, do implement stir, longest common prefix, since both of these, there's not really any novel solutions to be had with both of these problems. And so going forward, I think we're going to try and do trapping rainwater, right, in a new way, right? Maybe a brute force way, and then maybe we'll try and intuit the DP solution. I've read the DP solution a few times, but I think we could do this. And I think actually Thomas left a comment about this a little while ago. Think about DP. I swore. yeah, I sort of left a comment about this. There was a thing I was going to read before, but yeah. And as always, make sure to join the HCC. It is the Hyperbolic Coding Chamber. Thousands upon thousands of joining every single day. Infinite cheat codes, right? So you're going to want to join. We're also going to have a surprise appearance next week, right? Which we're going to announce. And it's going to be a musician. You might be wondering, why is the Hyperbolic Coding Chamber, right, the holy land of the algorithmic community, why is the special guest next week a musician? Well, you're going to have to join the HCC to find out. So we have 1 hour on the clock, right? I'm just going to jump into it. It's going to do implement stir longest common prefix, right? Trapping rainwater, and then we have to go back to value division. We got to stop running from it. So we're going to jump back. I'll do 30 minutes of trapping rainwater just so we time box a little bit, and we'll have to at least spend a little bit of time on evaluate division. So that's what we're going to start with. So let's just jump into it. All right, let's do it. So implement stir. So given two strings, needle and haystack, return the index of the first occurrence of needle and haystack. It's like needle and haystack are both strings, are returning a number. Or -1 if needle is not part of haystack. What should we return when needle is an empty string? This is a great question to ask during an interview. For the purpose of this problem, we return 0 when needle is an empty string. So if that's the case, then we can say if needle.length equals 0, right, then we're just going to return, if length equals 0, we're going to return 0 like they mentioned, right? So now let's try mapping the problem statement to the example. Given two strings, haystack and needle, return the index of the first occurrence of needle in haystack, or -1 if needle is not part of haystack. Right, so now we know that HELL is the haystack. We want to find LL, right? And then LL, the first occurrence of it is at index 2, so 0, 1, 2. So the index of where it starts. So that makes sense. Say PBA, right? And this doesn't exist within our haystack, so we return -1. Haystack is always at least one character, so is needle length, and they only consist of lowercase English letters. So this is interesting. I think I've done this problem. We've definitely done this problem before, but I think our previous solution was something like h times n, right? Where h would be the length of the haystack string, right? And for each character through, right, we actually are going to do n operations, right? And the reason was because, right, if, let's just say h, which is the haystack, right, is equal to hello, right, and n is equal to, right, LL, what we would do is we would start at h, I'll make this bigger, we would start at h, right, and then from this index we would go, right, from this index, right, and add to the length of n, which is 2, right, LL is length of 2, we would create a substring of the string starting from this index. So if we start at h, which is index 0, we're going to take the substring of hello, right, going from 0 to ll.length, which is 2, which actually gives us he. Now, does this equal ll, right? No, right? And that's why we're going to do h times n operations, right? But I think there is a version of this where you can actually do this in linear time, right? And I think what we'd have to do is just say, right, we could have the string, right, which is hello, right? And we'll say if we find, because we're going to be iterating over the string, right? And we'll say, okay, if car equals, right, n sub 0, right, which would be the start, right? So if it does, now we're going to have a while loop, right? And we're going to say, okay, while let's just say car sub idx equals, actually no, yeah, we could do something like a while loop, right? While, you know, n idx, right, is less than n dot length, right? And the whole goal, right, is to make sure that we continue iterating forward, right? So we'd say we start at h, right, which is here, and we're gonna say, okay, does h equal ll? No, we go to e. Does e equal l? No. Does l equal l? Yes. So now we know we have the start of our string. Now we want to make sure that when we're checking for the string, right, we skip those characters, right, which do not, now that we're checking for the string, now that we found the start of the needle in the string, we want to make certain that the process of checking, right, if this subsection of our haystack is equal to needle, we want to be able to do two things. We want to make sure that this string exists, right? And if it doesn't, we also want to not reprocess those characters if it doesn't exist. It's a really confusing thing to say. What I'm trying to say is if we have a string like HEL, right, and then HELL, let's say this is what I mean. If we have HEL and HELLL, and then I'll just lowercase this, and LL, and we're going to change our n, right, to be equal to LLL, right? So in our previous string, right, in our previous version of h times n, we'd go, okay, h, right, and we'll check 3 characters in front of it. Does HEL equal LL? No. Does ELL equal LLL? No. Does LLE equals LLL? No. The problem with this being that every time we check, every time we create a substring, right, we have to do pretty much n operations to create that substring, right? Because the problem is when we check HEL, right, if this does not equal our haystack, then we can kind of maybe we can't skip. I was thinking maybe we could skip, right? We could say triple L. But if we skip, right, let's say we do HEL does not equal LLL, right? We can't skip to this L, right? It does work in this scenario, but if we were looking for something like EL, we'd actually have a problem, right? If we remove this out here, or let's say we were checking for EL, we'd say, does HE equal EL? No, right? And so we'd skip all the way to L here. The problem is we can still actually find it if we do EL here. That's actually a problem, now that I'm thinking about it, because we can't exactly skip. Maybe a linear time solution is not possible. I'm wondering if it's possible if we did something like a divide and conquer. That would be confusing to implement though, because ultimately we're looking for this entire substring. H times n. I guess h would be the length of the haystack, where n is the length of the needle. Gotta be a linear time solution. I think there's another way you could probably, let's see, right, if we did something like this, is 2n or 2 iterations through h worse than, right, 1 iteration through h, right, times needle, right? If we had like a really large haystack, a really large needle, right? Then I would actually think this could be worse up to a degree, right? If H was equal to like 1,000, right, and N was equal to 999, the worst case there actually wouldn't be that bad. No, yeah, and actually we would end up searching the whole string. I guess the worst case for this is that our H is obscenely large, right? And our needle is at the end of the string, basically. So if we had an H, right, of 1,000, right, and N is equal to something like 35, which is at the end of the string, for our first algorithm, right, the one that's H times N, we'd end up doing like 35,000 operations, right? Whereas in the other one, we could end up doing just 2,000 operations. So I think we could do one in 2H time. Or maybe we could just sliding window pattern this thing. Might be overcomplicating it. I think we could probably sliding window pattern this thing. So we have our 2H version, right? What if we sliding window pattern this thing, right? We have hello, right? And LL. That's the case. We start at H, right? And the problem with, or the difficulty in the sliding window pattern is knowing when to restart, right? If H does not equal N sub 0, right, then we want to restart. So E does not equal L, so you start, okay, L equals L, okay, so then we go to the next one. Does L equal L? Yes. So then we could return it right there. And then if we had something like, yeah, I think we could sliding window this. The question is, when would we also return? I guess once our window length, if our window length is ever equal to needle length, right, then we would return, right, the starting index of our window. So I think we could sliding window this, sliding window, right, and it would be done in linear time. To do that, we need something like a left pointer, which would start at 0, a right pointer, which would also start at 0. So like while left, or no, while right is less than haystack dot length, right? So we'll have left and right, and our right is we're gonna be at 0, right? So we're gonna be at H, right? And so we're gonna want to grow our window. Our window is going to be always moving right, like moving to the right-hand side. So if that is the case, we'll say if haystack sub right is equal to needle and I think we're also going to do a third pointer, right, called end pointer, which is going to start at 0, and we'll say, right, if haystack sub right is equal to end pointer, right, then everything's fine, right? Because we'd say, okay, if we're at L, right, does L equal L? Yes. So we'd like to do end pointer plus equal 1. Right? And then the other thing we could check, right, is if end pointer ever equals needle dot length, right, then we know that we can just return left, because left should be the start of our window. And then, so let's check, we also need to increment right, and left. We need one more case. I think it's going to be this else here in this bottom case here. So we start at H, right? We're looking for LL, right? Does H equal L? It does not, right? And 0 does not equal needle length, right? So we're going to do right plus equal 1, right? Right is always going to increment, right? And since it's not equal, we're going to do left plus equal 1 as well. So now left is equal to E, left is equal to 1, and right is equal to 1. Now does right equal L? No, right? We're also I'm realizing we're gonna run it to restart. End pointer equal to 0 as well. All right, so now we're gonna be at L, right? So left is going to be equal to 0, 1, 2, and right is also going to be equal to 2, right? And then we're going to say if haystack sub right equals n pointer, needle sub n pointer, which is L, we're good, right? So we're going to add n pointer to 1. Then we're going to move right forward once, right? Does L equal L? It does. So now n pointer does equal 2, right? If we say if n pointer equals needle length, return left. So I think this might work. I feel like I'm missing a case though. In my mind, I think I'm missing a case. I think we should be okay. So we have Mississippi, right? And we're looking for ISIP. Right? So I wonder why this is happening, right? We do know that we get to ISSI, right? If we get to ISSI, we should return, an n pointer should return to 0. So the string we're looking for is actually ISIP. ISIP, when we restart, right? Once we restart, right? We end up actually restarting at S basically, right? Which means we can never find the string we're looking for. I think you could still do this in linear time. We linear time times H still do this in linear time. I think the process, right, we're looking for ISIP, right? Once we restart our end pointer, we actually end up skipping our new start that could have worked. So one thing we could do is keep track of new starts. I'm actually realizing this is not functionally that different to what we were doing before, h times n. The problem with the h times n algorithm is that we were checking on every iteration. You could also just check, right? We can also just do the substring operation. We can also just do the substring operation when the start matches, which would mean that our time complexity would actually be the number of start strings. Our time complexity would be the number of start indices, or the number of occurrences of the start of needle in the haystack. So, for example, our needle here is isip, right? And the number of operations we would do would actually be, we'd be searching through the array, right? We would do, I guess, h times I operations, right? I being how many times I appears in the string, which would be 4, which would technically be faster, but it's still, I think it's still h times. Or I guess it wouldn't be h times, I guess it'd be h plus, I mean, it'd be h plus n times I, which is technically less, but I want something that's just O of n. And in the worst case, we do h times n. The worst case, that the entire string is I, and the needle is at list minimum isip. So we'd still do h times n in the worst case anyway. I think there is an O of h solution here, but you have to iterate through the string twice. The worst case in that case, if you keep track of the starts, it would still be an optimization, but the worst case would still be keep track of starts. The worst case would still be an entirety, a string with a bunch of B's. Right, and all of our starts would be B's. I think of optimizations, and they're definitely better, but they're still O of h times n. Yeah, I think there's only an h times n solution here. It was fun to try to see. I'm actually curious if we read the answer, if there's a linear time solution. But in terms of the h times n solution, we can just iterate through the string with haystack, I being less than haystack dot length, I plus plus, right? And on every iteration, we'll just check, right, if haystack dot substring, right, starting at index I, right, and including the number of and the substring, right, starting at index I, right, and adding x number of characters that's going to be provided by needle.length, right, is equal to needle. And if it is, we return I. Otherwise, we return -1. Or maybe I think the substring function here is actually a specific indice in the string. So I think we're going to want to do I plus needle.length. Yeah, I think we're just using the wrong version. I think this is h times n, but I'm just curious if it's possible. There's no solution, but I'm curious if anyone came up with a linear time solution. This is linear time. L is equal to haystack dot length. L2 is equal to needle length. Okay, while I is less than the haystack's length, haystack sub I is equal to needle sub I, j plus equal 1, right? Which is the right hand side, I plus equal 1. Otherwise, if j, right, which is the length of the current, no. I guess, yeah, which is the length of the, right, it's the length of the current window is equal to L2, then it return I minus L2, else I is equal to I minus j plus 1. I'm pretty sure this isn't linear time. This is kind of exactly what I'm doing. This would be O of n h times n, or n times h. Because then he just moves I minus j plus 1, which is just like moving the pointer forward, right, 1 character. So I don't think that's linear time. Yeah, this isn't linear time either. I think this is why I think this the sub, I think it's just probably impossible. The implementation of substring takes h, right, I plus length. The substring function here takes, I guess it depends on the implementation. If we assume substring takes constant time, but it doesn't, because you're getting a substring from a string, right? And I also think aren't strings immutable in JavaScript? And I think they're immutable. They're immutable in JavaScript, but you can modify them. You just get a new string. But I'm pretty sure they're immutable. And well, no, it looks like he's changing it here. No, I'm pretty sure this would be h times n, I think. But this is besides the point. We're trying to get a different. We used to have other problems to do. I'll do longest common prefix. Actually, just to make sure I don't run out of time, I'm going to do trapping rainwater. So, given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. Each bar is 1. Compute how much water it can trap after raining. So we have an elevation map here. We have height, which is represented by this array, right? And so we have 0, right? 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1. So it looks like the elevation map, the numbers in the array actually represent the number of cubes, right? And it looks like the value or the number of the water it can contain seems to be a function of the boundaries between the water that is containing it. So if that's the case, right, we want a way to pretty much we want a way to calculate how much water is trapped, right? But there's no simple way to do that. I know of a solution that works in linear time and constant space, right? But I want to try a DP solution, or at least DP or brute force solution, right? And so to do that, I think we could do, I think it would be n squared to do the brute force solution, right? Because I think we could visualize it as 3 levels here, right? Where this one cube, right, keeps a range, right? It just assumes that it was able to capture all the water here. And then we could have this one push forward here, and then this third one push forward over here. And then if we go in the opposite direction, right, then we can subtract the values from both to get the height that exists, or the elevation of the water. But I'm not really certain what the left-hand side of the graph, or the left-hand side of the elevation map, left or right-hand side of the elevation map is displaying. It is unclear. I think we could draw this to make it make more sense. So yeah, I think we could draw this to make more sense. We have the elevation map, right? It's something like this. Right? And each is 1 block wide. So I guess in this graph, right, the number of water, say this is an awful drawing. I think we want something that makes a little bit more sense, right? Have something like this. We'll have 1, 2, 3, 4, right? And then we'll have right, we'll have something like this, right? And then they would each have their own cube, right? That one block width that they mentioned, right? And I think the one that we have right now looks something like this, where this one goes up to 2, right? And I think this one could also go up to 1 to start. And I think, right, if we assume this one, right, has water of 1, this one has a water of 1. So the answer to this one would be output would be equal to 2. And I guess what I'm trying to get at with the brute force version, right, if we can calculate, if we can create another elevation map, right, that looks something like this, right, where the elevation map would look like this, right? This would mean that the total number of water captured would actually be 1, 2, 3, 4, 5, 6, which would be an output of 6, right? And this elevation, or I guess this would look like the bit of water that was actually captured. So that array, right? Since there's 1, 2, 3, 4, 5, 6, and 7 elements in this elevation map, the output array of the water captured would look something like this, right? We have 0, right? 0, because there's a block here. There's a block here, right? Then we would have 1 block captured, right? But then we have this elevation of 2 here, right? And then we'd have 2 blocks captured, 1 block, and then 2 block, right? We do 2 plus 2 plus 1 plus 1 plus 1 gives us the value of 6. And that's going from left to right, right? So there's another angle, I think, right, where if we erase, right, the crazy one that we calculated, we know that the actual answer is actually 2, right? So if we erase all the nonsense, right, and then we go back to what we originally had in terms of the water that was actually there, actual answer looks something like this. But now we can go from the right to the left-hand side, right? And that would look something like this. So this one would be colored, right? And then we'd have the same thing, but in the opposite direction here, right? And if we'd have that array, that would look something like going from right to left, right? And the output here would be 1, 2, 3, 4, 5, 6, right? So the output here is also 6. What does the water captured actually look like, right? It would be something like 2, 1, 2, right? 0, 2, 1, 2, 1, 2, 0, right? Then we'd have 1, then we'd have 0, right? I'm also realizing we missed a 0 from going from right to left. By going from right to left, we had 0, 0, 1, 0, 0, 1. Yeah, I think we messed up. Let me see. Going from right to left, right? So we're going this way now. We'd have, no, we're going from, oh, right. So I'm getting confused. The array of water captured is left to right every single time, but right. So right to left, right, we'd have 2 blocks of water captured, 1 block, 2 blocks, 0 blocks, 1 block, 0, right, and then 0. Now, I think we messed up on our original one with left. This one looked something like this, right? And so we had 0, 0, 1. So this 2 should actually be a 0. I'm actually not certain why I wrote 2. I think I wrote the number of blocks that was actually there. I have 0, right? And then we actually had 2, right? Then we had 1, right? And then we had 2. Yeah, I'm not sure what I was going for, what I was doing here. We had 0, 0, 1, 0, 2, 1, 1, 2, and then the other one, right, was 2, 1, 2, 0, 2, 1, 2, 1, 0, 0. Now this, and I think what we're getting right is that the overlap of both of these graphs, right, is this one section right here, which gives us our output of 2. So maybe if we get the new sums of these values, since we messed up, right, the new sum of these values would be 1 plus 2 is 3, right? 3 plus 1 is 4, plus 2 is 6. So I think what we want to do, right, to get our value of 2, right, we want to take the absolute value of values that exist in both arrays, right? So we look at 0 and 2, right? The absolute value of the both values don't exist, right? So we want to ignore these two, right? There's no water here. There's water in this one, but there's no water in this one. There's water in this one, so we'll skip it. Water in this one. No water in this one, water in this one, right? But here we have actual water, so we'll take the absolute value of the difference, which will give us, it'll give us 1, right? There's no water in this one, no water in this one. Then there's these two exist, so we'll take the absolute value of the difference, which will give us 1. Water in this one, no water in this one, water in this one, no water in this one. So we basically need two, need to generate 2 water arrays, right? And then we'll take the absolute value of difference if both exist as output, right? So to do that, we have to iterate twice over their height, right? So we can say const, right, starting from left going to right, it's going to be an empty array. We'll do the same for right. So the first thing we have to do is do it for left. So we do, right, for const, right? So I guess the question is, how do we build that water array, right? And I think that value is just going to be the maximum value, right? On each iteration, we're just going to push that onto the array. So our maximum value here is 0. Maximum value here is 1. So we push 1. Our maximum value here is 1. So we push 1. Then our new max is 2. We push 2, 2, 2, 2, right? And then our max value here is 3. So we do 3, 3, 3, 3. In the cases, right, where we push 2 on, right, and there's actually the elevation map, right, in the other array, the right array, it's actually also going to map to the same value, right, in the same index, so they're going to subtract. The absolute value of the difference would be 0, so it won't affect our answer. Say const elevation of height, we can just call it ele of height, right? We'll say let max equal infinity or negative infinity, and then we'll say max is equal to the math.max of max, right, and ele, and then for left we'll do left.push max. Then we can reuse the same thing for right here. We can push that. We'll set max equal to negative infinity again, except we want to go the opposite direction, right? So we're going to have to change our method. I is going to equal to height.length minus 1, while I is greater than or equal to 0, I minus minus. And then we'll just say const L is equal to height sub I. Now we have both of these arrays, right? They're going to be parallel, the same length, right? So we'll say, right, we'll say the output, which is a number. We're going to say for let I is equal to 0, I is less than height.length. They're both going to be height, length, long, right? And then we're going to say if left sub I and right sub I, right, if the values are greater than 0, right, then we want to say output plus equal math dot absolute value of the difference of left sub I minus right sub I. And then we should be able to return output. Forgot the equal sign. I also just realized I think I actually didn't have this up on the screen when I was using the iPad, so that's a little nutty. So we're off by 1. So this one would look like take the max. It's strange that it's off. In this case, our graph would look like this. We have 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 3. This would be 1, 2, 2, 2, 3, 3, 3, 3, 3, 3, 3, 3. So I wonder if we had a smaller graph. If we had a smaller graph, so we have 0, 1, 0, 2, 1, right? We have a 0, 1, 1, 2, 2, right? 0, 1, 1, 2, 2 for left, right? And for right, we should have 1. Oh, I think the values in the array end up in the wrong order. Iterating in reverse, right? So I think what we need to do, I don't think there's an automatic reverse. What we could just do is do stack treat it like a stack instead, right? And then reverse the output, right? And then we just say dot length does not equal 0, right? We'll do right dot push stack dot pop. Then I will hide these two. And our answer is just off. Yeah, I'm not making sure I'm fixing the right problem. Let me make sure this scenario, at least when I print left and right. So for left, we should have 0, 1, 1, 2, 2. Okay, and for right, we should have 1, 2. Right, so we have the right thing, it's just in the wrong order still. So if I print stack, oh yeah, stack would be empty, so we could print it up here. Wait, so it's already in the... Right, yeah. Oh man, we're just trying to solve problems that don't exist. I need to actually figure out what's wrong instead of just guessing. right? And then I'll print, so dot log left and right. So in a small graph, we have 0, 1, 1, 2, 2, 0, 1, 1, 2, 2, 0, 1, 1, 2, 2, and then we'd have 1, 2, 2, 2, 2. All right, so these both values don't exist. These do exist, so we get 1. These do exist, so we get 1. It was 0 and 0. But their output is only 1. Take the max of the bound. So I think our heuristic might be too simple, right? Why are we taking the max of the left and the right? Why are we taking the max, right, of the elevation? So here we'd have 0 water captured, and this one has, this should have 2 captured, which it does. This one is a tough one because I can't see it any other way than, yeah. I remember reading the solution where they did something like this, but I'm pretty sure they used 2 double for loops. Using 1 for loop, which I think makes the a little too simple. I think we want to take the minimum. Yeah, let's go back to the other version. Maybe we'll have, these are just other problems solved with VP that we'll just have to return to. This one, right, I think the way that I solved it before was that we noticed that the minimum amount of water we can capture actually exists between the minimum of the value between two elevations, right? So we know that we can only at max trap, at least the height of the water can at max be 1, right? When we're bounded by another boundary that's taller than us. So if we start at this elevation and search for the next or the nearest height, right, that is greater than or equal to us, we get this one. Then figuring out how much water we actually trapped is just a function of taking the sum of the minimum of the two heights, right, subtracted by the elevation, right? So if the minimum of these two heights is 1, which is this cube here, we can do 1 minus 1 gives us 0. 1 minus an elevation of 0 gives us 1, right? And 1 minus 2 gives us a negative value, right? So we'll ignore the negative values. Works here as well, because we have 2 and 3, right? We'll take the minimum, we'll find the next boundary that's greater than or equal to us, right? That's going to be this one here. And then we can just take the sum, right, of the minimum, the sum of the series going to the sum of the sequence going up to the boundary that's greater than or equal to us, right? Where we do the minimum minus the elevation. So 2 minus 2 equals 0, 2 minus 1 gives us 1, 2 minus 0 gives us 2, 2 minus 1 gives us 1, right? We ignore negative values. The problem is, right, that it only works going from a smaller boundary to a larger boundary. When we're starting from a larger boundary, it's harder to know, right, how much water you can actually get, right? Because you have to find like the minimum over this entire, the maximum over this entire range, right? Whereas if we're going from a small to a higher, we can stop once we meet one that is greater than or equal to us. So the best approach is a two-pronged approach where we'll iterate starting from the left and the right sides, right? And then we'll simply go from the smallest, start from the smallest side and just keep going, right, until we meet a boundary that is greater than us, calculate the water, that'll be our new point, and so on. So to do that, I'm going to need a left pointer, which is equal to 0, a right pointer, which is equal to height.length minus 1. Do while left is less than right, right? We're going to have water, which we return, right? So we're going to need a water variable, right? And of the left and right indices, right, like we said, we need to choose the smallest one of the two, right? Because we always want to be going from low to high. So we'll say if height sub left is less than height sub right, right, then we'd be in business, right? We'd want to go from left, starting from the left side and go towards the right side, right? In this case, that's actually true, right? Since 0 is less than 1, right? So then we're going to want to try and calculate as much water as we can, right, until we find a new pillar that is greater than or equal to our value. So we can basically just do, right, left plus equal 1, right, to iterate forward once. We'll say, but first we're going to actually need to keep track of our start, right? So we can say const start, right, is equal to left, right? Because we need to know the height that, or the height that we started at, right? So we can say height sub left and then we'll say while height sub left, right, which would now be 1 because we started at here with 0, right? We'll do height sub left is equal to 0, so this is our highest boundary, right? We're going to do left plus equals 1. We're going to say, okay, while start is less than, or while height sub left, right, is less than start, right, then we'd like to calculate some water. But in this case, there's nothing to calculate, right? Because the next boundary we stop, right? So our loop never runs, right? And so let's try for this angle, right? 1 going up to 2, right? Start would equal height sub left. We do left plus equal 1 to start here. And then we'd say, well, height sub left, which is this 0 here, is less than start, which is 1. 0 is less than 1. Let's calculate some water. That's going to be water plus equal height sub left, which is 0. So we're going to say start minus height sub left, right, which should give us 1 minus 0, which gives us 1. Right, and then we'll do left plus equal 1. Then we'll check, right, we'll be at height sub left, which is 2. Is 2 less than start? It's not, right? So we should be good there. Then we can actually duplicate this for our else case and just swap the direction of a lot of the variables. Start is going to be equal to height sub right, And our progress step is actually going to be right minus equal 1. We can change left to right here, right? And we'll say if height sub right is less than start, right? Then we want to start calculating some water, but only by doing right minus equal 1, right? With height sub right. So this would be linear time, constant space. I'm hoping we can do the DP solution another time, but that is a wrap.